All right, today we're going to talk a little bit about what are called rational expressions. Now, a rational expression is similar to a rational number. It's just an expression that you can represent as a fraction. The only difference now is we may have some x's or x plus 4s or 4x plus 1s or expressions mixed in. Rational expressions have a couple of fine-tuned details that we have to be careful of when we're simplifying them. The biggest rule is we can only divide away items that are multiplied, such as over here at the left, or sorry, in the middle here, 4x plus 1 over 2. We might be tempted to say, oh, 4 over 2, let's divide that away. But remember that 4 is multiplied by x, which is added to 1, which means unless you're going to divide both 4x and 1 by that 2, we're going to distribute that 2, we're not going to be able to simplify that down. Now, other things we have to worry about are excluded values. What about if there's an x on the bottom, such as 3 over x plus 4? What would happen if we plugged in a number like negative 4? Well, we would end up with 3 over negative 4 plus 4, 3 over 0. And anything that makes the denominator 0 we call an excluded value. So again, we don't want to plug in things that are called excluded values because we can't divide by 0. And to simplify a rational expression means that we need to eliminate any common factors that are in the numerator and the denominator, things that are both multiplied into the top that are also multiplied into the bottom. So let's look at a couple examples real quick. If we're dividing a normal fraction over here, one thing we normally would do is say, well, hey, 28 and 35. 28 is really 7 times 4, but 35 is really 7 times 5. Because they both have a 7 in them, or 7 multiplied in both the top and the bottom, that's how we normally simplify fractions. 4 over 5 would be my answer. Well, the same thing goes with x times 8 and 3 times x here on the bottom. Again, if there's an x multiplied on both the top and the bottom, then we can eliminate that, and simplifying we would get 8 over 3. Again, the same thing goes for quantities. If x plus 4 is multiplied by 3, and x plus 4, note the quantity, is multiplied by 15, then I can eliminate the entire quantity. And also we'd want to note that 3 over 15 has a 3 in common. So again, I can actually call that 1/5. I would divide a 3 out of both parts, as well as divide away those x plus 4s, and we'd end up with 1/5. So down here in the lower left, those 2's that are multiplied in front are going to leave us with x on top and x plus 5 on the bottom. Now here's where you got to be careful. It looks like x over x, but remember x is added to 5 in the denominator. So I can't divide away items that aren't multiplied. I can't divide away terms when they're added to other terms. So x over x plus 5 is the best we get. Now here you might be tempted to think about those x squareds, but remember x squared on the bottom is really x times x. So what we really want to do is take away that x on the front and one of the x's on the bottom, and we will leave ourselves with x squared plus 6 all over x. Again, we can only divide away items that are multiplied. Talking about those excluded values, here's kind of the idea to that. If you ever see these formulas here, where we're looking for what can't I actually plug in, again, any value, right, that would make our rational expression undefined. Values that are excluded are values that make the denominator equal to 0. So looking at our first expression here, I would have to take that denominator, and if I said 2 times x plus 5 equals 0, well, divided by 2, that's x plus 5 equals 0. And if I subtract that 5 over, then I am not allowed to plug in, right? Excluded value would be a negative 5. Take a second, think about these expressions at the bottom. Now you might recognize x squared plus x minus 6. Again, I'm not worried about x plus 4, but that expression on the bottom is probably something that can be factored. The same thing goes for x squared minus 49. Factor those out and see if you can't figure out what the excluded values would be. All right, taking a look at our factoring, you'll notice the expression in the middle, only the denominator. Again, not worried about the numerator. Only what makes the denominator 0 is going to be a problem. So I factored into x plus 3x minus 2, which means negative 3 and positive 2 would make the denominator 0. They would make the expression undefined. They would be divided by 0 and make it undefined. Now on the bottom, this is that difference of squares. So x squared minus 49 is x minus 7, x plus 7. And 7 and negative 7 would be issues. Now you'll notice that if I plug 7 in the top, I would also get 0. Well, now having 0 over 0 isn't any better. So notice we're not worried about simplifying this time. I'm just worried about what makes the denominator 0 from the very beginning of the problem. Let's do a little bit of practice with simplifying. See if you can't take these expressions. Using that idea we just talked about, I would highly recommend factoring. If you factored the top and factored the bottom, remember we need things that are multiplied in order to simplify. So take a second, factor, and divide things away if you can. All right, so we got some answers for you here. In this first problem, we just factored a 2x out of both the top and the bottom, basically canceling those away, and we end up with x minus 3 over 3x. On the one on the right, again, we factor the top, we factor an x out of the bottom. You'll notice we get that x plus 1 in common. Hopefully you got x plus 3 over x. On the bottom, we had to get a little bit fancy. I noticed that x minus 4 over 4 minus x, they're very similar. So if I factored a negative out of the bottom here, again, I reordered the bottom as well. Negative 4 plus x is the same thing as x minus 4, think commutative property, which means that there's an x minus 4 and an x minus 4, both top and bottom. But now if I divide those away, remember there's still a 1 left on the top and a negative 1 left on the bottom. So 1 over negative 1 is negative 1. So I did the same thing on the top of this one. I just noticed that I've got some kind of funny stuff going on. I like having x being the first item, or first term. So I factored out a negative 1 and kind of switched the order. Then on the bottom, I factored out a 2x. It just so happens that left me with 5x minus 12. Factor those away, and you'll get your negative 1 over 2x. Now that idea of simplifying can sort of be expanded a little bit as well if we talk about multiplying and dividing. When we're talking about multiplying fractions, remember we always multiply straight across. So when we're talking about 2 over x times 3 over 5, that's 6 over 5x. When we're talking about dividing, remember we don't divide straight across. Instead, we need to flip that second fraction first. We need to take 2 over x times 5 over 3, thus getting us, again, 10 on the top and 3x on the bottom. But after that, it comes down to the same simplifying rules. I can only divide away things that are multiplied. So let's look at a couple of examples real quick. If we're taking a look at these fractions here, again, if we're multiplying, we're going to multiply straight across. So we're just going to say this is 2 times 3, which would be 6, and x to the 4th, over, we have a 15 on the bottom, x to the 4th as well. Well, now since those x's are multiplied by our coefficients, then x to the 4th over x to the 4th disappears, and 6 over 15 would really be the same thing as, oops, switch back to the pencil there, 2 over 5. And it just makes sense. We started with 4 x's on top and 4 x's on the bottom. All the x's basically cancel each other away, and we can simplify our numbers down to a 2/5. Take a second, try that other fraction, and let's see if your answer matches mine. All right, so I multiplied the top and multiplied the bottom. I noticed that 24 over 40, 4 went into both of those, so I called it 6 over 10. And then I also took an x out of both parts. X squared over x, I can cancel 1x away. So I left myself with a 6x over 10, but oops, I didn't take enough out of there. 6 over 10, I could also take out another 2. Or if you take an 8 right away out of both 24 and 40, you'd get it down to 3/5. So 3/5 times x, or basically 3x over 5, would be a good final answer. Let's try a few more tricky ones with a little bit more going on. Try these two. Again, thinking back to what we did with simplifying. Can you factor what you're given, such as x plus 3x plus 1? Then, combining those two things, looking at what do they have in common, multiplied both top and bottom. Well, I notice an x plus 1 and another x plus 1. So I'm going to take those out. Okay? Recognizing that, again, as long as they're multiplied, we can divide those away, and we're left with a 4x over x plus 3. Try that next problem. Factor what you can, simplify what you can, and let's see what you get. Again, x squared minus 25 can be x plus 5x minus 5. We multiply those two fractions together. We got what's on the top and the bottom. And now I can divide away. Well, hey, I've got an x minus 5 on both top and bottom, leaving me with x over x plus 5 quantity squared. Again, factoring allows us to see what's multiplied, and if we have things that are multiplied on both the top and the bottom, we can divide them away. Now, division, again, adds just a small twist. The first thing we need to do when we're dividing is take that second fraction and find its reciprocal. So we're going to flip that over right away. Now we're fully ready. Let's multiply it into one fraction, look for what's in common top and bottom, and we'll eliminate that away. So the same idea, let's flip this fraction over. Now we can save ourselves some time when we do, if we really think about it. There's a 2 in both this 8 and this 2. So as I'm going to go ahead and rewrite that second fraction upside down here, right? 4 minus x goes to the top, and 2x goes to the bottom. At the same time, why not factor away that 2? So that now when I put them as one fraction, I can immediately notice, hey, I've got a 4 minus x in both the top and the bottom. I also have another x on both the top and bottom. And since the entire numerator canceled away, don't forget that leaves us with a 1. And 1 over 2 times 2 just becomes a 1/4. Let's do a little more factoring. Again, save yourself some time since these are division problems. When you flip that fraction, go ahead and factor the other fraction at the same time and save yourself some steps. Then when you combine the two fractions, we'll be able to see what they have in common, and we can get rid of, again, that x minus 1. We can get rid of that 2, and x minus 3 over x is our answer. Again, factor as you go, so let's factor the bottom. We're going to turn it into multiplication. So we're going to flip this over, but at the same time, I'm going to factor the top. I notice there's a 3x in both parts. So x minus 6 goes to the top. 3x times 2x plus 3 moves to the denominator. Combine those fractions, and let's get rid of the x minus 6, and let's get rid of the 3x, leaving us with, again, 1 over x plus 4 times 2x plus 3. How about we do just a couple more examples just to help ourselves out. Try these out. I'm going to pause the video now. See if you can't simplify and see if you can't figure out what they're going to look like in the end. All right, in that first one, again, we can divide away the 2. We can do it right away. If you want to combine and call that 4x squared, you can. But remember, 4 is multiplied on top, 2 is multiplied on the bottom. Why not just divide it away? Same thing goes for the next fraction. Factor the top, flip the second fraction, and we'll notice we've got x plus 1 multiplied on both the top and bottom. Let's divide it away. And finally, flip that second fraction. We've got 8's on top. We've got x squareds on both top and bottom. 2 left on the top means 2 over 1, essentially just a 2 for an answer. I hope that helps you with simplifying rational expressions. Remember, factor. If you're not multiplied on both the top and the bottom, you can't divide them away. Factor, 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 and see what you can eliminate. Have a great day.